Good morning, children. I'm happily welcome you to chemistry class. I hope you all are staying safe in this pandemic situation. Be safe, take care of your health, and side by side, study your lessons. Now, we are in the lesson 2, types of chemical bonding. In this lesson, we have 3 types of chemical bonding: electrovalent bond, covalent bond, coordination bond. We already completed electrovalent bond, covalent bond. Now, we are going to discuss the remaining one, coordination bond. Coordination bond definition: the bond formed between two atoms by sharing a pair of electrons provided entirely by one of the combining atoms but shared by both is called a coordinate or dative bond. Here, in this type of bond, no single electrons are transferring, no sharing of electrons, only pair of electrons is taking part in this bond formation. Examples for this coordination bond: water and ammonia. A pair of electrons taking part in this bond formation. It is not a shared pair. It is known as a lone pair of electrons. So here the lone pair of electrons taking part to make a coordination bond. Coordinate bond formation with water molecule. Here water is reacting proton H plus ion and giving out OH3 plus, making a coordinate bond. Hydrogen has a 1 valence electron and oxygen has 6 valence electrons, but it has a 3 pairs. The 6 valence electron is converted into 3 pairs of electron, that is lone pair. Then the 1 pair is shared by the proton, that is H, and it is making a OH3 plus ion. This is making coordinate bond. Here oxygen is giving out 1 pair of electron to hydrogen, so that it is called donor. Hydrogen is gaining an electron, so it is called as acceptor. This is how we need to mention a coordinate bond. Conditions for the formation of coordination bond. One of the two atoms must have at least one lone pair of electrons, because the lone pair of electron only sharing. That's why at least one atom needs a pair of electron. Another atom should be shorter of at least one lone pair of electrons. Here they given an example, hydrogen ion. That means one has a lone pair of electron, another one has only one lone pair electrons. So this is the condition for the formation of coordination bond. Next, we are moving to the topic co-ionic bond. So a coordination bond has the properties of both covalent and ionic bonds. Therefore, it is also called co-ionic bond. See, the transfer of electron is taking place, so it is acting as a cation. That's why we are saying as a co-ionic bond. Coordination bond is represented by this symbol. Atom, which provides electron pair for the formation of coordination bond, is known as donor. Atom or ion sharing the donated electron pair is known as acceptor. Formation of H3O plus ion and lone pair effect of oxygen atom. Here the Lewis dot structure is given for hydrogen as well as oxygen atom. It is nothing but to represent a valency electron. Hydrogen has a 1 valency and oxygen has a 6 valency. This is how we need to represent a Lewis dot structure. Covalent bonding in water. The OH bond water molecules are polarized due to the large difference in the electronegativity values of the oxygen and the hydrogen atoms. We already know in the covalent bond formation, electronegativity only plays a major role. O is obviously non-metal and H is may be a metal. So the electronegativity difference are high. That's why it is acting as a covalent bond. The large electronegative differences makes this molecule as a polar molecule. Polar is nothing but of the electronegativity difference. That one was represented between these water molecule. See OH, H, that is H2O. Here H2O, one pole is acting as a positive and then another pole is acting as a negative. This negative pole again combining with the positive pole of other hydrogen atom. So that's why the water molecule is formed in the covalent bond formation. Dipole-dipole interactions. What is dipole-dipole interaction? In a covalent bond formation, we have a mutual sharing of electrons between non-metal and metal. So in that, the electronegativity plays a important role. The difference between the electronegativities, they are acting as a polar compounds. Here also, the dipole is nothing but of one end is, that is one pole is positive and another pole is negative. So between these different charges attracting towards it, that is called dipole interactions or attractive forces between polar molecules. Example, we already discussed water molecule. In the water molecule, the hydrogen bond is a special class of dipole-dipole interaction due to its strength, that is the electronegativity differences. Formation of ammonium ion and lone pair effect. Ammonium ion NH4 plus. Nitrogen atom and hydrogen atoms taking part in this ammonium ion formation. Nitrogen atom has 5 valency electrons and the hydrogen atom has 1 valence electron. See, through this dot picture, they are representing how these lone pair of electrons sharing between the ammonia and proton to make a ammonium ion. Nitrogen has lone pair of electron and hydrogen has shared pair of electron. That is, hydrogen has only one electron, but nitrogen has a lone pair of electron. That one represented in the arrow mark, that lone pair was shared to H plus ion and then it is making a NH4 plus ion. See here, it is making a coordinate bond. The lone pair of electron was shared to the hydrogen atom. That's why it is making a ammonium ion. Here, the bond formation between the nitrogen atom and hydrogen ion is a coordination bond. Formation of hydroxyl ion. Hydroxyl ion formula is OH minus. It is formed from water molecule. The hydroxyl ion is formed when one hydrogen ion is removed from the water molecule. When H2O loses one hydrogen atom, it becomes OH minus. When OH group is present, we know that is a base group. So these hydroxyl ion also strong base. OH is formed in this hydroxyl ion is represented by this electron dot structure OH and then minus. See here, the hydrogen is sharing one electron to the oxygen atom. It is not a coordination bond, it's a covalent bond. Self-ionization of water. Water molecules contain 2 hydrogen atoms and 1 oxygen atom. A positive hydrogen ion is formed when water is ionized. Water molecule is ionized, it becomes OH minus hydroxyl ion and H plus hydrogen ion. Here the single water molecule is taking part. Then again 2 water molecules are taking part in the reaction. It is giving out hydronium ion H3O plus and OH minus. When one water is taking part in the reaction, it is splitting OH minus H plus. Then two water molecules, the OH minus, two times forming OH minus and H plus. In this OH minus, again combining with two individual hydrogen ion, it is forming H3O plus and remaining one OH minus. So here also it is making one positive ion and one negative ion. Here you have important questions from lesson 1, periodic classification of elements. Along with the question you have an answer also. For your board examination, you can get the questions like this. So gone through these questions carefully. You can take down the notes from your classwork. While coming to the school, you can submit the classwork. Chemical bonding lesson is over. If you have any doubts, I'll clarify in the class. For this lesson, also we have the important questions to discuss. The next class, I'll give the questions. We can discuss it. For your further understanding, you can repeatedly watch this video. Thank you, children.